All right, welcome back. And I've taken a few minutes just to tidy up my workspace here, so I've got a little bit more room. And now we're going to do a titration of a known quantity of the must or the juice. Okay, so we've already made our stock solution. I've just put a label on here, but I've got a 0.1 molar KOH stock solution that I'm going to use to titrate the sample. Now, you don't have to use KOH, as I said before. You can use sodium hydroxide, and the maths will still work out the same. It's just sodium hydroxide has a lower molecular weight than potassium hydroxide. No problem. I'm going to put that up on the YouTube channel anyway, how to do the calculations for both. So I've got here glassware. I happen to be able to get my hands on glassware like this. However, don't fret if you don't have any. You can go onto eBay and find it for pretty much dirt cheap. You don't want to be paying a lot of money for all of this. Some things you don't need. So I've got a stir plate and a stir bar. At least you don't need that. You can stir your solution just by moving your solution around in a flask. In fact, that's how I used to do it in high school many moons ago. Okay? All you're really going to need is a proper graduated burette. So you want quite an accurate one. So this is a 50 ml burette, and it's got 0.1 graduations on it as well. And as I already said before, you're going to want to get a volumetric flask. This one's a 250 volumetric flask, and that's just so that you can prepare with complete accuracy your stock solution of KOH. You need to know how much is in this flask, or else the analysis is a waste of time. Another thing you're going to need is a graduated pipette, or something that can accurately get your solution of juice into a flask. So I want to, in this experiment, take exactly 5 milliliters of this juice and put it in the flask. We need to know the precise volume of juice going into the flask, and then we need to use a precise volume of KOH solution to titrate. So if you can't get accurate measures on these things, then it's just a waste of time. Okay, but again, don't fret. You can get one of these on eBay for about £1. They're cheap as chips. Right. So the way the experiment is going to go is that I'm going to add 100 mils of distilled water. I've got a pure water source here in the kitchen. If you don't have one, most people don't, just buy some distilled water. And I'm going to add 100 mils, and I'm not going to be accurate with that. I'm just going to go to the graduation on the flask. But then I'm going to introduce accurately 5 mils of the juice into the flask. So we have a known quantity of juice in the flask. I'm going to add indicator, and I've got phenolphthalein indicator here, which is a classic acid-base titration indicator. You can, I've looked on the internet, you can get a thing of phenolphthalein for, I think I saw it for about £15 for a jar that'll last you forever, basically. So it is available online, so it's not hard to get your hands on. Okay, I'm going to load the burette. Easiest way to do that is just to drop it down right to the bottom. You can buy a little funnel if you want, and the way you'll be taught in high school chemistry or first year chemistry is you never pour from the stock bottle into the burette. Okay, that's just an absolute no-no. I'm here to break the rules. Hopefully I don't make a mess. Okay, but it's my chemistry kit. I can do what I want. Now, you want to make sure that that's closed. The next thing I want to do is make sure that my burette is as level as possible, and that's because it's got graduations. Okay, and now what I want to do is I want to bring the level of the KOH, excuse me, right to the 0 point. And I want to be as accurate as possible. So with the burette, you've got a little knob to turn here, which is a little tap to open it up. And you just want to go as slow as you possibly can. Okay, make sure you got a beaker underneath to catch it. You do not want to use your flask that you'll be using in the experiment. You don't want any KOH in there to begin with. Okay, and then the way you do it is you look, there are two sets of lines on a burette. Okay, and I want to make sure that my eye level lines up the two sets of lines. So the 0 line, for example, goes all the way around the burette. So I want to make sure that my eyes are right level with it so that one line overlaps the other. And that means I'm not looking at a funny angle. Here we go. You're going by the bottom of the meniscus. So it's where the bottom is, that's what your volume is. Okay, always collect the little drip at the bottom, and that's it. So I added more KOH than I needed above the line, and that's so I could bring it down to the line and fill all the empty space in here as well, if I needed to. Make sure I get all the bubbles out. Okay, so this KOH solution is, we know it's a 0.1 molar solution. It's now at 0, so we can start our titration. So the next thing is, I'm going to fill this up with approximately 100 mils of pure water. Now the graduations on a flask are not accurate, they're just a suggestion. So I've got 100 mils plus or minus something, maybe plus or minus 5 mils, I'm not too sure. There we go. The next thing is that I want to make sure I take my juice, and I've already filtered this through cheesecloth. I'm just giving it a shake just in case any acid has precipitated out as say for example a tartarate crystal or something, and that's highly doubtful that anything's precipitated out, but I want to make sure it's all in solution here. There we go. Now it's a matter of using your pipette. Okay, the pipette has graduations on it as well. I've just washed it out with water is all. Okay, so I know that I can accurately dispense 5 mils of solution. So I'm going to do that. I'm naughty. You can get little hand pumps for them as well, but because this is a safe sample, i.e. it's something that you can drink, I'm just going to pipe that up with my mouth. Okay, so very, very naughty. Okay, you can see there, I've got more than I need. So now I'm just going to roll my finger until it starts to flow out. And the slower you move your finger, the slower the liquid moves through the pipette. And I just want to be as slow as I can getting to that 0 mark. And again, use the bottom of the meniscus. And yes, I have one eye closed. I want to really zero in on that. Spot on. Okay, this calls for accuracy or it's a waste of time. Always get the little drip off. Okay, and now I've got to be careful because I only want to take this down for 5 mils. See how fast that went? 5 mils spot on, take the little drip. That's it. I'm going to take the rest of my sample back as well in case I want to take a look at it a little bit later. So now I've got a flask with about 100 mils of water, but with 5 mils of juice. Now it's time to add my phenolphthalein indicator. This is an indicator that is colorless under acidic conditions. I'll add about 4 drops. One, 2, 3, 4. Actually, I'll add 6. Why not? Okay. So the way this works is that at acidic conditions, the indicator is colorless, just like this. It's a clear solution. And then as it changes pH and becomes basic, I think it's around a pH of 8, but I could be wrong, the indicator goes pink. So when it's basic, it turns pink. When it's acidic, it's colorless. And we're going to use that color change to assess when we've added enough base from our burette, our KOH, to neutralize the acid in here. Okay? Because if I keep adding base, what happens is it reacts with the acid and it neutralizes it, and then there comes a point where it's reacted with all the acid that's in here, and the next drop then makes the whole solution quite basic, and the indicator then changes. See, it went pinky purple and then the purple disappeared. Let's do it again, see if I can get a better angle. I'm adding some base and it goes pinky purple and then the purple disappears. Yeah, do you see that? So what's happening when I add the base, it hits the indicator and the indicator turns color immediately. But then as it gets mixed up, the acids react with the base in there and neutralize. There we go. All right, let's keep going. This is a pure joy, and I've already added about 1 ml. So now I'm going to take my time going really, really slow, drop by drop. Oh, that might be it. That might be it. That's it. Oh, wait. One more drop will definitely put it over. Yeah, I can see just this little pinky hue there. We've already added, wow, almost 5.5 mils. Let's just put one more drop just to send it right over if I can. So we've added 5.4 mils right now plus a drop. That should do it. There it is. It's pink. If I go right up, you can see that I've added 5.45, almost 5.5 mils. Okay, so what have we learned? Well, we've learned that we used exactly 5.4 milliliters of a 0.1 KOH solution. So we used 5.4 milliliters of this 0.1 molar KOH solution to neutralize all the acids that were in a 5 milliliter sample of juice, okay, plus 100 mils of water, but water's neutral. Okay folks, I couldn't wait and needed to crunch the numbers, and again I'll put this on my video as well so that you can follow along. It's pretty straightforward to do the calculations, but if you're not used to doing calculations like this, it could seem quite foreign and quite challenging. So just try to follow along as best you can if you've not seen this before. We calculated, or excuse me, we experimentally used 5.4, precisely 5.4 milliliters of 0.1 molar KOH solution to neutralize, to get rid of all of the acids in 5 milliliters of grape juice. Okay, so those are the two major numbers we need. The calculation, or the formula, excuse me, of molarity is just the number of moles divided by the volume. And therefore, if we want to solve for the number of moles, we rearrange it, and the number of moles will equal the molarity of our KOH stock solution times the volume used. So it was a 0.1 molar stock solution, and we used 0.0054 liters. Now this calculation's always in liters. You have to be really careful, and you need to convert from milliliters to liters. So that's 0.0054 liters. So 5.4 milliliters is equal to 0.0054 liters. Then we can calculate the number of moles, and that's 0.00054 moles. So you can see how these numbers are quite small. So you have to get used to working with these small numbers. But it's accurate. So I know that to get rid of all the acid in 5 mils of juice, we used 0.00054 moles of KOH. Now, the question is how much acid was in our 5 milliliters of juice? There are two ways to express this. The French way, which is expressed as sulfuric acid, H2SO4. I'll do that first. We say that the number of moles, this is a formula, a known formula, is equal to the mass over the molecular weight. So then we want to rearrange to get the mass. We want to know how many grams of acid are in our sample. So mass is equal to the number of moles times molecular weight. See, it's just a rearrangement. And we've already solved for number of moles, so we know that that's 0.00054 moles. And now we have to multiply by the molecular weight of sulfuric acid, H2SO4. Okay? The molecular weight of sulfuric acid, you can just look that up online. It's 98.079 grams per mole. So when you multiply the number of moles times the grams per mole, you get grams, and that's equal to 0.0530 grams of H2SO4, because remember I'm just expressing as H2SO4 in 5 mils of juice, because the 5 mils of juice was our sample size. Now, you have to multiply 5 mils of juice by 200 to obtain 1 liter of juice. And the amount of acid is always expressed as grams per liter. So that's why we're doing this step. So therefore, 0.0530 grams of H2SO4, and that's in 5 milliliters of juice, multiplied by 200 will give 10.6 grams per liter of H2SO4, or we can just say 10.6 grams of acid. Now, that's the French way to express. The North American way to express the amount of acid is via tartaric acid, and it's a touch more tricky. Okay? And it's tricky because there are 2 protons or 2 sites in tartaric acid where you can have neutralization. All right, that's why it's more complex. In H2SO4, for what we're doing, there's only 1, but in tartaric acid, there are 2. So therefore, it takes 2 molecules of KOH to neutralize 1 molecule of tartaric acid. So therefore, we have to take our number of moles of KOH, so remember we calculated that up here, and we have to divide it by 2 to get the number of moles of tartaric acid that we've neutralized. So it is a little trickier. When you do that, then you can get the mass of tartaric acid, and that's just the number of moles calculated, which is now half of what we saw before, 0.00027 moles of tartaric acid, multiplied by its molecular weight, which is larger. It's 150.0787 grams per mole. Okay, that's the molecular weight of tartaric acid, and that will equal then 0.041 grams of tartaric acid in 5 mils of our juice. Now again, we need to multiply that by 200 so we can express it as grams per liter of juice. So when I do that, it equals 8.10 grams per liter tartaric acid. Okay, so we've now got 2 ways to express. We've got H2SO4, the French way, and we've got tartaric acid, which is the North American way. Now, I've got the Book of God beside me here. Okay, this is Techniques in Home Winemaking. I talked about it before, and it is phenomenal, and I recommend it. And if we go to page 122, we can see that the author has put a table here to show what is the TA, so that's the total acidity range, for the must, which is what we just analyzed, in grams per liter. Dry white, that's what we're making, you want for the must 7 to 9 grams per liter. This is expressed as tartaric acid, okay? So we want somewhere between 7 and 9 grams, and we have calculated 8.10 grams. So we are spot on in this range, okay? It also says what the pH is for what the pH should be for dry wine, and we're in that range as well. So everything is rolled over beautifully tickety-boo, and that makes me happy. So we now know total acidity expressed in acid, tartaric acid for the North American way is spot on. Or if we want to do what the French do, it's spot on as well, just expressed a little differently. Okay, so that analysis complete, I know that I do not need to add any tartaric acid to my must before fermentation. So I can just go ahead and ferment, which is very exciting. All right, ciao.